So what I'm going to be doing then is I'm going to make my slide, and when you do this you're going to be doing it obviously super carefully, but I don't want you to get too bored when I write, you know, E. coli and B. subtilis on here. So you're writing on one end of the slide. Importantly, you're then turning it over. We're going to put our bacteria onto the other side of the slide, okay? Now, this is called an inoculating loop. Has anyone used these before? It's a little wire metal loop, yeah?
In chemistry.
Okay, brilliant. Now, this is not sterile at the moment. I've just got this out of the drawer. So I need to sterilise my inoculating loop as part of making sure that I'm not introducing contamination in. And then I need to sterilise it again after I've taken my sample, so that if there are pathogens in here, if there's been mutations, they're not going to grow on here ready for the next person to pick this up. Okay, so how do we do that? This is the fun bit. Just make it go really hot, and all those microbes now going, ow, and dying. Oh, yeah, nothing can survive that heat. So this is one way of sterilising. Some of our inoculating loops are plastic. Please don't do this because they will melt. If they're plastic, they should be coming out of a sterile packet. They should only be used once. Okay. So my inoculating loop is now sterile. Brilliant. It's now really important that I keep it near here and I don't put it down on any surface. Okay. So now I'm going to do the transfer of the bacteria. This might pong a bit, sorry if it does. One of the other aseptic techniques is called flaming the neck of the bottle, because we want to create actually a convection current here as well, away from here, so no contamination is going to get in. It's another kind of safety measure. We don't want any contamination going in. So what we do is, this is where you have to be a little bit dexterous, or get your friend to help you. It's important that you don't put anything down, and you're going to start running out of hands at this point. Okay, so this is called flaming the neck. You're literally just passing it. So we're creating currents, taking any microbes, and also if there was any aerosols in here, there might have been some cells that were already kind of not in the liquid but maybe in suspension in the air inside the bottle. Those are being killed. Okay, so we don't get aerosols into the room. So just kind of 4 or 5 times like that. Do not hold it in for very long, it will break and you will get a handful of E. coli, which is not a nice thing. So also while you're doing that, that's quite good. My inoculating loop is cooled down, because if I just put a hot inoculating loop in there, it's going to kill things, okay? Which doesn't matter really for this practical, but when we do other microbiology and you're actually trying to grow bacteria on purpose, that would then not work. So I'm going to give it a good stir, and I'm going to start transferring over some liquid onto my slide. I need about 1 centimetre in diameter of liquid, making sure hopefully I'm picking up absolutely hundreds of cells as I do this. Okay, so that's now there. I'm going to flame the neck again. Notice I didn't put the lid down anywhere. And then, oh, it's a bit stingy now. I'm going to sterilise my loop. So everything we've done so far is called aseptic techniques. Asepsis is the absence of contamination in the room or in the culture, and the way that we achieve absence of contamination is we do various aseptic techniques, like washing my hands, cleaning the desk, having a bath and going, all that stuff. Yeah, after that, can anyone else smell the delightful smell of bacterial cultures? Just me so far. Awesome. Oh, why did I switch that off? Okay, so as Mariana quite rightly said, we also need the Bunsen, because we now have cells which are just kind of mixed into the liquid on the slide, and we need to make sure that they don't just wash off down the sink. So I actually need this. Oops. Back on again, and obviously I've had my safety goggles on the whole way through. Did anyone spot that? Yeah. Okay, so what I'm going to do now is I'm going to get this. At the moment there's liquid on there still, and I just want that to kind of air dry, so I'm just holding it up here for a bit. Just want that to dry off. So that's just evaporating off, that's fine. And then if you've got your method in front of you, what we're now going to do, we're on this bit here, drying and fixing the smear. So it's going to take ages, but but we're all good with this step, right? Yeah, this is just a demo. Okay, now we're going to fix the bacteria so the cells don't fall off. So this is the bit where you pass it very rapidly through the hottest part. So where that blue cone is, if you can see that, is the hottest part of the Bunsen flame. You see the top of the blue cone? And we're going to pass it through rapidly for less than a second. And we're going to do that twice. Okay. You can check you have not overheated it by putting this on your hand.
That doesn't sound like
I don't think we need to do that, okay? We're just having a go, aren't we? It doesn't matter, this isn't a core practical, I'm not looking for any CPAC skills. So this is the bit of this that I'm not happy with. Apparently this should feel warm to the touch but not too hot, but the only way of finding that out is to put it on your skin, which we are not going to do, okay? So, hopefully, it's literally that. Like that. That should fix. It won't because I've still got water on there. You have to make sure it's really dry to start with before you do that. But in theory, this now has bacteria on it. Okay, right, now we really can switch that off. All right, now we need to head to the sink. Just 2 minutes. Yeah. Now I need your help. Someone's going to time me, please. What's the timer? Timer. And I need someone to actually read out so that I can time. Oh. Okay, that's fine. So what you will see is these contraptions, some glass rods. So at this point you're going to be working over a sink so that the stains and everything we're using is going to drip down into the sink. Okay, so we're going to take our slide.
For how long do you want to be timed, sir?
Well, this is where I need also someone to be reading out the method. So who's got their method sheet in front of them? This is the staining part.
Oh.
What goes on first?
Here. I think.
I just need some gloves.
I think. You need to leave the stain on for 1 minute.
Which one?
Crystal violet.
Okay. Right, so this is one of the ones, crystal violet is one of the ones, when you look at the HAZ card, it's like, oh my goodness, it can be fatal if it's swallowed, it's toxic, it's corrosive, all of those things. So this is why I'm now wearing gloves and I'm going to be super careful with it. I've got my goggles on. So aim is we are not getting this on our skin, but also what you will see on the HAZ card is it's already a dilute solution. Okay, this is already a dilute solution. When this was made, it was quite a dangerous thing because you have like a solid that you're dissolving, but this is already a dilute solution of crystal violet. It's nearly as old as rhodium. Look at that. Okay, so what am I doing? Just putting some on,
Yeah.
and leaving it for a minute. Ready? Really important to remember which side your bacteria are on when doing this practical. So remembering that they're on the slide that doesn't have the writing on it.
Is that why you put the writing on?
What do I do next so I can get ready?
Then you're going to wash it off with an iodine.
Okay, so we're going to use an iodine wash. So that says Lugol iodine, but this is called Grams iodine. It does the same thing, and that's where it gets the name of the procedure from. So it's a bit like the iodine that you guys would have used for starch testing. This is like yellowy brown when it comes out of the bottle. This isn't being used as a stain this time though, it's being used as a mordant. Who can remember what a mordant is? Tell me when a minute's up.
Not yet.
Shouldn't she be washing it into the tray?
It's going into the sink.
Okay then.
1. Done.
Okay, and then how long do I do this for, or I just do it?
1 minute.
Okay. Washing it or covering it?
No, you leave it with the iodine on for a minute.
Okay, so this is a mordant. Does anyone remember? What's happening? So the crystal violet's gone into the peptidoglycan. It's interacting. It's a stain that interacts with that chemical. The iodine is now fixing. So a mordant is a chemical that fixes something into place. So where you've got thick peptidoglycan, That grams iodine is now fixing that into place. The crystal violet is being fixed. Where you've only got a thin layer of peptidoglycan, there's not enough peptidoglycan for the grams iodine to do that, so it's not being fixed. Okay, what comes next? Just so I know.
Wash it up with wash it off
With
ethanol.
Yep.
Now.
Wow. Okay. Until what?
Move the side to the white tile,
Just until most of the iodine's off.
and then you do it until the washing's a pale violet colour.
Okay. So this is where you're looking at what's coming off. It's all right because the sink's white, so I'm just looking at the sink, and you're just seeing, okay, it was dark purple coming off, and now it's quite pale, so that's fine. So the ethanol is really important. So what it's doing is, for the gram negative, it's now decolorizing. It's washing off the crystal violet that hasn't been fixed. It's also dissolving that outer membrane as well. So the ethanol's kind of got two jobs. Now what do I need to do?
Wash off the ethanol with water.
Wash off the ethanol with water.
It says tap water. Doesn't tap water have microbes in?
Could well do. We're using distilled.
Ah, women of class.
Yeah. And then, next step.
Apply
Now
the
we
saffron
come to
in.
So when you put it on and got a timer for 35 seconds.
Okay. So the saffron in is a lovely, lovely dark red colour. This is our counter stain. So again, you're just going to flood it on and leave it for how long?
30 seconds.
30 seconds. Okay, so we can see that you are handling these stains, but you can see that it's safe. I'm not covered in stain. I haven't, it's only if you get overexcited and knock something.
Wow.
But that's why whenever you do a practical, you're on your feet. You don't sit down unless you're using a microscope. You can. By that stage, everything's.
You need to wash it off with water.
Thank you. By that stage, you've probably got a cover slip on. It's all fine. Okay. Brilliant. Now, when you look at that with the naked eye, ooh, interesting. There are two slides there. You won't be able to see anything. These cells are tiny, 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 like 5 micrometer diameter. So smaller than animal and plant cells. So we then need to start doing some microscope work. And we need to be using the oil immersion lens. And when it comes to it, when you're doing this, I will help you use the oil immersion lens, which is the ×100 objective lens. But essentially what you're doing with that, you put your slide on the stage and then you swing the objective lenses round between the 40 and the 100, and you put a blob of oil on top, and then you swing the ×100 lens so it's in contact. The lens is in contact with the oil, which is in contact with the slide. So you're looking through oil because it needs to refract differently at that magnification. It can't pass through air. Yeah. But you'd look at it under ×10 ×40 first to see, well, you'll see then is like purple blobs and red blobs, and then you can zoom in on them. Okay, we're going to let this slide dry though, aren't we? Does it say about air drying it before you put it on the microscope? Yeah? So does that feel a bit more manageable? Because I think yesterday it was like, oh help, this is a really scary practical maybe. But also it's, you've just got to be a little bit on it when it comes to doing it with timing and having everything kind of lined up ready. All right, so you will be doing this next week. What we need to do now then is to finish our risk assessments off, because this is a CPAC skill. So now that you've seen me do it, talk about it, find your table that you started yesterday. What are the hazards? What's the chance of them happening? What's the consequence if they do happen? Combine those two things to make a risk rating, and then put the control measures. What do we do to keep ourselves safe? Okay?
Madam, what